Kia ora, I'm just sitting at home this Sunday and I'm freaking out on behalf of you guys, and I have decided to make a video covering off how to get all of the achieved skills on the marking grid for linear algebra. So I've got the marking grid here, and so today what we're going to do is we're going to have a look at how to form an equation for linear models, how to form an equation from a graph, how to graph a linear model, how to use substitution to calculate a distance or time, graphically show intersection points, use simultaneous equations to locate intersection points, and communicating answers. So I'm just going to look at the achieved skills so that you guys have a video that you can refer back to. Okay, so let's get straight into it. So we've got this netball trip practice assessment, and you will have Desmos open like I've got opened on the left hand side of the screen. So let's just start from the beginning. Draw the graph of plan C on the same grid as above. So what we're going to do is we're going to get plan C. So we got here, plan C can be described by the equation C equals 0.25k plus 250. You know what? In Desmos, you can just type that in straight away. So I can type that in. I can go C equals 0.25k plus 250. Now, I'm going to give you guys the right scale on your Desmos, but if you don't have that, you know you can just zoom in and out with the scroller like that. So as you can see, this is plan C modeled, and actually, to be honest, we have now graphed a linear model. It is that easy. So that is one of the 3 skills required, although we haven't communicated anything yet, so it's a little bit dangerous at this point. What I want to express really quickly is that C is just a new letter that we would normally put a Y there, and K is just a new letter where we would normally put X. And as you can see, instead of the X-axis, we've got K for kilometers, and instead of Y, we have the cost. So when you're answering questions, we're going to have to talk about how many kilometers and what the cost is. As you can see from this graph, if you go for 600 kilometers, if I click here, 600 kilometers costs $400. So that's going to be the context. Damn, that's expensive. But it's a netball trip. That's probably about right. Okay, so write the equations for plan A and plan B. So as you can see, if I zoom in, I'm just going to make it a little bit bigger. But on this here, I have a couple of lines that have been drawn on, and they may not be super clear. So what I'm going to do is I'm just going to grab them and chuck them onto Jamboard. So we've got Jamboard up here, and we're going to spend a little bit of time learning how to form an equation from a graph. So let's just give that a second to load. So I've got the graph here, and to form an equation from a graph, you're going to have to find 2 things. The 2 things you're going to need to find are the y-intercept, and all that means is where the line crosses over this black arrow that is pointing upward. It's called C this time, but normally we call it Y. And also you will need to find the gradients, and as you know, gradient equals m, which is rise over run. So we're going to have a quick look at doing those now. So let's start with plan A. Plan A. And what I'm going to do is I'm going to do plan A in a certain color so we can see what's happening, and then I'll do plan B in another color so we can see what's happening. Let me just work out how to do that here. Okay, I guess we're just doing a little blue dot here. Why not? So we've got plan A, which is here, right? So this line that's going across here, that is plan A. Now, when you are dealing with a horizontal line, it's really easy to find the formula, because what is the gradient of a horizontal line? Well, how much is it rising? It's rising 0, so it has no gradient. So all we actually need is a y-intercept. So where is the y-intercept? It's over here at 500. That is the point where it crosses over that arrow over here. So this is the y-intercept for plan A. And there is no gradient, so what I might write is m equals 0, and then the y int equals, where is it? 500. So that's all of the information I need, and then I can make an equation. So the equation is going to be y equals, with a gradient of 0, 0x plus the y-intercept, which is 500. But we don't write it in this form. We're going to have to write it in the taxi form. So I'm going to start again, and it's actually going to be c, or the cost. See how our y is now c. C is equal to, and the gradient is 0, so 0 times the amount of kilometers, which is the thing that's down here instead of x, plus 500. But we know that if the gradient is 0, 0 times k, 0 times anything just disappears. So actually, plan A is just c equals 500. And if you want to get good marks, you need to write plan A. You need to communicate what you have found. So plan A, C is equal to 500. That's it. So now let's go on to the next plan. We've got plan B over here. So we need to find two things for plan B. We need to find the y-intercept and the gradient. So let's find the y-intercept. Well, the y-intercept is where the line crosses over this arrow here, and you can see that it crosses over here at 100. So we now know that the y-intercept for plan B, y-int equals 100. Okay, what else do we need to find? The gradient. So now to find a gradient, we need m equals the rise. I don't know how good this is looking. That's alright, I'm happy with it. Rise over the run. So what we need to do for that is we need to pick 2 points and then find out how much it goes across and how much goes up between those 2 points. So normally the easiest point to pick is this point here. And then I go up until I find 2 numbers that are probably nice to deal with. So see how this point, normally it's best to find it on the crosshairs. It's like I'm aiming for a crosshair. So see how we've got a nice, I can see that this one's 200 and this one's 200. So I'll use that point. So now I draw a little triangle to join those points together. And then I ask the question, how much has it run? So that's this thing here, run. So it's gone from 0 up to 200. So the run is just 200 minus 0. The run is 200. It's gone across 200. How much is the rise? Can I fit that in here? Yes. So the rise, it's gone from 100 up to 200. So how much between 100 and 200? 200 minus 100, that is 100. So its rise is 100. Now, don't get confused, because the scale on the x and the y axis, they're not actually to scale, because this one has gone across 200 in the same amount of distance it took for that to go up 100. But don't worry about that. So we've got a rise that is 100 over a run that is 200. So that means the gradient is, so let's cancel out some of those zeros. So it's 1 over 2. And if you guys like decimals, that's fair enough, but I don't like decimals. But I'm going to write it anyway, which would be 0.5. So now we have a y-intercept and a gradient, so we can do the equation for plan B. So it's going to be C equals, and then we put the gradient. I think you guys like decimals, I'm going to use that. 0.5, and then I'm going to put a K plus the y-intercept, which is 100. So what we've now done is we have formed an equation from a graph. So let's get this back over here. So that is step 2, all done. We formed an equation from a graph. So we've got this equation here, and we've got this other equation as well over here. Now, the thing is with Desmos though, it doesn't actually work when you move it in. So we've got a way to fix that. So what I'm going to do is I'm going to chuck this on this side for a second so we can remember our formulas, and we're going to put these into our graph over here. So notice when I go C equals 500, it doesn't actually add in that horizontal line that we wanted. So one of my students found a solution. What he did was he just put in 0k plus 500. So that's a way that you can make sure that it looks good. What I do is hold my mouse over this and change it to a nice color as well. So let's make sure they're different colors. I'm going to make this one purple today. So now I've got my plan. Ooh, I should really label these, shouldn't I? We'll label them in a bit. Okay, so I've got plan A in purple. Maybe I should make it the same colors. So I did a blue for that one. So let's hold this down and make that blue. Plan B I did in red, so maybe I should change this one to a new color like a green, because this was the plan that was already given, but we'll have a look at that soon. Okay, so we now have a new plan, which is plan B. So it's C is equal to 0.5k plus 100. And then I'm going to make this one, by holding this down, I'm going to make this one my red plan. So now I've got my 3 plans, and actually if I go to the marking grid now, you can see that I have formed an equation from a graph because I took that y-intercept and that gradient, and so I have now formed an equation from a graph. Formed equations for linear models, I guess I have done that when I got this, what line was it? This green line up here. I made an equation. And then graph a linear model. Yes, I've graphed that on Desmos. So actually, I've already got 3 skills, but we need to have a look at the other ones as well. Use substitution to calculate a distance or time, graphically showing intersection points. So to do that, all you do is you click on the intersection on the screen and you can just copy it over here. So what I do is I just click here, memorize it, 600, 400. So over here, bracket, 600, comma, 400. And if you want, you can label those. So I can say, let's say, oh no, actually the label's already good. So I'm just going to have that as 600, 400. This intersection here is also good. So I could do that, 800, 500. And I can tick this to have a label, and then I can click on this. And these are all of my intersections done already. 1000, and what was the other one? Was it 500, 1000? Oh, 1000, 500. Nice. So then those are labeled. So actually I've graphically shown intersection points. Now, I still haven't used substitution to calculate a distance or a time, and I still haven't used simultaneous equations. So let's do that. Okay, let's have a look. Which plan would be best if they only traveled exactly 400 kilometers? So 400 kilometers, if I go to Desmos, I can see down here the kilometers is on my x-axis, but we're calling it k today. And you can see here we have 400. So what I need to do to make that work is, I'm going to try this, but it's not going to work. I'm going to write k equals 400. No, I know it doesn't work. What I'm going to do is I'm going to write x equals 400. It's the only thing I can think of. I'm actually going to make this dashed just to make it pretty. So what I'm going to do is hover over this, tap this. Might do it in black because that's cool. It's a little bit thick. Let's go one. Beautiful. Okay, so now, which plan were they best if they only traveled 400 kilometers? For achieved, I would recommend just clicking where these intersect with each other. So if you click on them, then you get the information that you need, and then you can write about that. So I'm going to show how I would write about that on Jamboard. So whereabouts are you, Jamboard? You're here. Okay, let's open a new Jamboard. And the question we're trying to answer is somewhere. I want this one. I want to, which plan would be best if they traveled exactly 400 kilometers? Let's drag this into Jamboard, make a new text box, and we'll answer this question. So on your book, what I would recommend for this one here is for 400 kilometers, you click on this. So I know what the plans are, or have I memorized what the plans are? I've got them over here. So plan A is in teal. So let's go and start writing about it. So I can say plan A will cost, and so I can look at my coordinate over here. Plan A is in blue. Plan A will cost how much? For 400 kilometers, so that's the first number, 400 kilometers, it will cost $500. Plan A will cost and do it in context, $500 to travel 400 kilometers. I think we do RE actually in New Zealand. So what you want to do is just have some statements that look like this. And if you want to cheat, you could just, I'm just going to copy paste because it's going to be the same format. And then I'm going to go plan B. And what was plan B? Plan B was in red. So plan B will cost, and then we go the red one. Look at that, 400 kilometers, $300. So I just changed that to $300. Now I'll grab this, copy paste it, and do it again. And we'll have a look at plan C. So plan C is in green, so it's here. So 400 kilometers is $350. So I'm going to put that and write $350. So if you do that, also what you should do is probably, after you've seen them, 400, 300, just add them in. 400, 300, and then put a label on that. This next one was 400, 350, so open a bracket, 400, 350, and then label on that. Then finally 400, 500, 400, 500, and then I can chuck a label on that as well. So see how all of my intersection points are nice and labeled now. Let's have a look at how we are going for getting some marks. Where are you? You're there. Cool. So which plan would be best? So we haven't actually answered the question yet, but what we have done is we have graphically shown some more intersection points, and we didn't even use substitution. Whoopsies. I'll show you how we do substitution in a second. But so I need to write an answer here. Plan B is the best because it is the cheapest at $300. So that's in context, I've answered that. Now, if you wanted to find this information using substitution, let's have a look at how we would do that. So to use substitution, plan A has the formula here, C equals 0k plus 500. So we would go C equals 0k plus 500. Then we would go down here and we would go C equals 0, whoopsies, and the amount of kilometers, we're just going to substitute 400 in for k. So here, 400 plus 500, well, 0 times 400 plus 500, C equals 500. So that is how you would use substitution to do it. Let's have a look at plan B. I won't do plan C because I think it's a little bit of a waste of time. To be honest, I want to make this video as short as possible. So plan B's formula is the red one, so it's this 0.5k plus 100. So C equals 0.5k plus 100. So C is going to be equal to 0.5, and we're substituting in 400 kilometers plus 100. So 0.5 times 400 is 200, so it's going to be 200 plus 100, and then so C is equal to 300. So that would be how you would use substitution to solve those. But remember, the other option is to just look on the graph. So we've done substitution now. Let's just tick that off. Substitution complete. Okay, finally, let's just have a look at using a simultaneous equation to find an intersection point. So that's going to be the last thing we have a look at. So what I'm going to do is we're going to try and find an intersection point. So we're going to find the intersection of plan B and plan C. So to do that, we've got to find our two equations. So plan B, I can't remember the colors at this stage. Pretty sure, I'll double check because I don't want to tell you a lie. Plan B, we did on my dash. Plan B is red and plan C is green. Plan B is red. So plan B is C equals 0.5k plus 100, and then plan C is C equals, and it is the green one, 0.25k plus 250. Okay, so we're going to use simultaneous equations to solve this. Now, the trick here is that C is equal to C. So you can just put these things equal to each other. So what I'm going to do is I'm going to substitute this C, which I know is equal to this equation, and I'm just going to put it because I know also that this C is equal to this equation, so I can just put them equal to each other. So 0.5k plus 100 is equal to 0.25k plus 250. I'm going to move all of the k's to one side and all of the numbers to the other side. So this side has a higher value of k, 0.5k, and this has got 0.25k. So what I'm going to do is I'm going to minus 0.25k on this side, and I'm going to do the same on the other side, minus 0.25k. So then what it ends up being is, what's 0.5k minus 0.25k? Well, that's 0.25k, and then everything else remains the same there. And that is equal to, and 0.25k minus 0.25k is just 0, so all that's left on that side is 250. Nice. So now let's move the numbers to the other side. So to do that, there's a plus 100 here. I'm going to do the opposite of that, which is minus 100. By minus 100 on one side, I have to do the same on the other side, minus 100. So then it ends up being 0.25k, and that is equal to 250 minus 100 is 150. So now I need to get this to being 1k. How do I get from 0.25 to 1? Well, 0.25 is a quarter, so what I'll do is I'll times it by 4. And I'll have to, if I'm timesing that side by 4, I'll also times this side by 4. So I'll end up with just a k on this side because 0.25 times 4 gets me to 1. And then k is going to be equal to 150 times 4, which is 600. So now I know k equals 600. Let's solve the other. We're nearly there. So k equals 600. We then just substitute it back into one of these plans. This one looks the easiest. So substitute back. Substitute. Yep. Substitute into that one. So 0.5k. Well, k is now 600. Whoopsies. So 0.5 times 600, that is, why does this thing make itself so big? I don't want me to be like that. Have I got like enters down here? I do. My bad. Okay, so you want to be a bit bigger, please. Okay, 0.5 times 600, we decided that that was 300 plus 100, so then C equals 400. So now we know K equals 600 and C equals 400. Let's check if that's right. Look at this over here. You can see that 600, 400. The K value between those two is at 600 and the C value is at 400. So then you could write it in context and you could say Plan B and Plan C cost the same at 600 km. Cost the same, and I'm going to say which is $400 each. So there we go. We've now shown every single possible achieve skill that you can use inside your assessment. Now, one last tip is you have to communicate those answers. So let's just see how I have communicated those answers. So here I've got communication. I've said what is actually happening rather than just the numbers. It's 600 kilometers, which is in context, and $400. And I've used the word cost, and I'm talking about the plans. Over here I've communicated saying the answer in context. Also, I've said over here, I've shown my working out, which is a form of communication. So yeah, that's how you can get an achieved in the upcoming assessment. I hope that was helpful.